There's been a quiet revolution in electric power transmission. The Arlo pole has come to Australia. The jumble of lattice-work towers carrying high-voltage transmission lines and ugly wooden poles carrying lesser voltages has become a blight on our landscape. Since the 1960s, electricity authorities have started to take note of the growing public disenchantment with the pollution of our visual environment. The Transfield Group, one of Australia's leading constructors of transmission lines, started to search for an alternative to the present welter of non-standard forms of high-voltage carriers. One concept attracted their attention: the Arlo pole. The Arlo pole is a structural system consisting of a series of high-strength steel tubes of incremental diameters nesting one inside the other. The tubes are spirally welded for increased strength, and each section is fitted with a flange at its base which locks against its immediate predecessor when the tubes are extended. The Arlo pole was designed, developed and patented by Mr. Bill Archer and Mr. Arthur Lowe in the United States. It contains all the ingredients to satisfy not only the functional requirements of electricity authorities, but also the aesthetic needs of an ecologically minded public. As an added bonus, it is amazingly simple to transport and erect. Each of the individual functional elements is given a uniform coating of heavy galvanizing, internally and externally, thereby guaranteeing its durability, under normal conditions, for approximately 30 years. The poles can be easily painted over the galvanizing, adding as much as 10 years to the lifespan of the pole. Because of its basic simplicity, the Arlo pole system can be adapted to fit the requirements of any transmission situation. There are only two sets of variables: the number and diameter of telescoping tubes to achieve a required height and load strength, and the depth and diameter of the foundations for a given pole. While the poles to fit a given situation are being fabricated, the appropriate foundations can be laid at the same time. The depth and diameter of the foundations will vary with the size of the pole, the load it must bear, and the type of soil. The foundations being installed here, for example, will reach to a depth of 15 meters and are designed to support a pole 20 meters high, which must withstand a combined horizontal load of 40 tons at 15 meters height, or a maximum moment at the base of the pole of approximately 6,100 newtons meter. The foundations are economical in area and can be installed with a minimum of dislocation, even near a busy footpath. When a hole has been excavated to the designed depth, the reinforcing metal cage inserted and the concrete poured, The actual supporting base for the Arlo pole is positioned, levelled, and the concrete left to harden. One of the big advantages of the Arlo pole is ease of shipping and handling. Even a pole that will reach a height of 26 meters can be neatly tucked away on the back of a truck, along with 3 others, delivered to its destination, offloaded and positioned on its base with a small crane and a crew of 2. There is a ring of securing bolts which fastens pole to base, and then it's all systems go for erection. Not all workers can put up an Arlo pole quite this quickly, but the normal erection time is literally only a matter of minutes. What distinguishes the Arlo pole from all other hollow steel poles is that it is extended by pumping it full of concrete at 2,750 kilopascals. This method allows a relatively light structure to become 60% stronger than conventional hollow poles, and makes erection a simple, rapid operation, saving time and labor. Anyone who has watched the hazardous operation of erecting a latticework tower will appreciate the elimination of dangerous risks to the men involved. Each of the sections of the pole extends until collar and flange lock, and it reaches its full height. Arlo poles can also be pre-stressed to allow for an asymmetrically loaded system. Arlo poles can of course be used in roles other than power transmission, such as lighting poles, structural columns for monorails or cable car systems, highway posts, and so on. There is no alternative in the foreseeable future to the overhead wire transmission of high voltages, but there is a need to improve the unsightly clutter they cause, particularly in residential areas. The Arlo pole, with its simplicity of manufacture, ease of handling, its strength and durability, its speed of erection, and above all its aesthetic appeal, fills this need at costs which are comparable to present systems. Transarlo was formed in 1973 as a joint venture between Transfield and Arlo to manufacture and install the Arlo pole in Australia. The Arlo pole system is not new. It has been thoroughly tested in America by the Tennessee Valley Authority and other major electricity authorities in the United States, Japan, and the Philippines. The Transarlo engineering staff has all of the expertise and experience behind it to be able to advise and assist power transmission authorities and industry generally on the application of this remarkable development. The Transarlo staff can also provide detailed case histories and comparative costings of installed lines.